see that fluorescence laser spectroscopy. Basically, the molecule drift through the laser focal point. That very small volume, and water doesn't give the fluorescence in that region. But once the peptide labeled with the fluorescent emitting the dye molecule, when they go through the focal point, it's just like that. They give the fluorescence, give a signal. And we are recording those, how do you call it? Signal. If you have signal, you have a positive, like 20, 30, a photon, right? And then if no peptide going through, then it has nothing, or it's just noise. So those things are kind of biochemical stuff. But that is what I did 20 years ago. So this is the kind of research we talk about. We're doing the graph with fluorescence energy transfer. Fluorescence resonance energy transfer, so it's called fluorescence. A day?
No, like a week ago.
A week ago. Why?
Well, because when water dissolves a solute, its freezing point goes down.
Yes. That is what we taught in the thermodynamics. I think Gen Chem basically just they use what do you call it?
The Clausius-Clapeyron?
Clausius?
Well, are you talking about an equation?
Yeah.
Do you mean like the natural log of P2 over P1 equals negative change in enthalpy over
What do you mean P to P1?
partial pressure?
Oh, that is. I don't think when you talk about the lowering.
Oh, you're still talking about that equation?
Yeah, basically, I think it's a chemical potential. Chemical potential reduced when you have solute.
Is that about kinetics?
Not kinetic. Kinetics is about how fast a reaction goes. Thermodynamics is on the chemical potential. When you let's see. Oh, the temperature. I will show you.
The change in temperature equals I KFB.
I K S
K sub F.
K sub F,
Yeah.
B. You learn this?
Yeah.
Okay, interesting. What is this K sub B?
The some kind of constant relating
K
to.
sub F,
Oh yeah, K sub.
freezing.
Yeah.
B is boiling.
Yeah, I got the two mixed up.
Yeah. But I think when you reach to third year or second semester of the second year, you will learn the 3301, that is physical chemistry 1. So that is the thermodynamics. And people find it very difficult. A lot of equations.
Is it about H, S, and G?
HS,
H, S, and G?
oh, HS and G, yeah, give free energy, right?
Yeah.
Yeah, those are fundamentals of science. In fact. That's very, very good. In fact, I would encourage you, when you have time, you can read the thermodynamics, those things. Once you understand, it will be very useful. Because you can see this world, you can use the thermodynamics to explain everything.
Yeah, like it explains whether something happens, right?
Yeah,
And what makes something happen.
yeah, those the 4 seasons and the temperature and even the soda, the carbon dioxide dissolved. How much carbon dioxide dissolved in soda? Yeah, physical chemistry, in fact, is a foundation of the science. Of course, based on that, you can do the organic chemistry, inorganic synthesis. So those are involved in breaking chemical bonds, forming new molecules. But the physical chemistry basically study the molecule without breaking chemical bond. Even if some kind of chemical bond we call the van der Waals bond, that is basically the weak intermolecular interaction.
Oh yeah, that's just London. Wait, is it London?
Frank London? What is a London?
Like London dispersion?
Oh, dispersion. Yeah, those nomenclature. Yeah, the more you study, the more you can use the nomenclature to discuss this. Those jargon words. For entry, but eventually you need to use the words understandable by general public to describe, for example, why we put salt on the pavement, right? When it's particularly ice. And also, have you thought about the figure skating, the skate on the ice?
Yeah.
Why they can skate? Why the slippery under the, how do you call it, the skate, under the skate,
Well, it's because
the metal.
ice is less dense than water, and ice skates have this blade that they focus the pressure into,
Uh-huh.
so that like increases the pressure because it's force over area, right?
So when you increase the pressure at under the skate,
Mm-hmm.
what happened to that ice right underneath
Well,
the ice?
well, since water is more dense than ice, like ice is like being compressed into water because it's just more dense, right?
Oh, you are using the density?
I guess.
No. It is also related to the
Thermodynamics.
freezing point. When you have pressure, press that point, that pressure will force the ice, the freezing point to become low. Just that location, right under the skate. And you can imagine the skate athlete, they do it very fast, right?
Mm-hmm.
How do you think that time, maybe millisecond or nanosecond, right?
Mm-hmm.
So that means as soon as you press that ice, there's a water layer is created, or you turn the ice right under the skate to water. The
And-
small layer, that water is slippery.
So this happens right as the ice skate touches.
Yes, when you have the metal, whatever pressure, you will because you have a skate, it is like a knife, right?
Yeah.
So that is very small area, but the high weight
Mm-hmm.
mass press on it. That means that the pressure, the force per unit area become very high. And then it turns the ice into water. And that layer of water exists momentarily between the skate and the ice. So they form a layer. And then just that layer makes ice so slippery.
So ice without any water would not be slippery?
Interesting. That is a good question. The ice itself is slippery, right?
Mm-hmm.
But that skate press that area, that form a groove of small groove of water. How to call it? Channel or canal?
Canal?
Canal, maybe. Anyway, but basically from a water groove,
Mm-hmm.
then that you can search internet when you get home why from the thermodynamics point of view why the state is
So it's got to do with the
pressure changing the melting point.
okay.
The time the ice increases. So
Does this have something to do with how, like, in a gaseous reaction, like exerting pressure on the system forces the reaction to the side with less moles of gas?
we are talking about changing between solid phase and the liquid phase. We are talking about gas phase.
Yeah.
Here we don't involve gas phase. But the changing of the boiling point that will involve gas phase, right? Boiling point. This is the transition from liquid phase to gas phase. Basically, extra heat is needed to free the molecule interaction. And that is why you boil the water. You need heat, right? Stove heat. Provide the heat. That heat basically, have you heard what is the word? Enthalpy?
Enthalpy, yeah, the H thing.
Yeah, H. Enthalpy is a word for heat. The entropy is higher order concept, but the enthalpy is the heat. And so you need the boiled water. You have to heat the water.
Yeah.
Because why do you need the heat?
Why do I need the heat?
Yeah.
Wait, can you repeat the question?
Why do you need to heat the water in order to boil the water?
Because you have to raise it up to its boiling temperature. And
Why do you have to raise to a certain temperature?
because at that temperature, the gas and liquid phases are in equilibrium.
Okay, so this is the only observation. But from the physics point, from the chemistry point,
So the average kinetic energy is higher, and then
you're right. Because the molecule has to overcome the intermolecular attraction. Because they are attract one another, right?
Yeah.
They bond together. But when you heat, what happens? Then each molecule has more and more kinetic energy. They're bouncing around, even in the liquid. And when you heat enough high temperature, that means each molecule has enough average energy. That energy can overcome this attraction force, right? Then they can get to space, right? It's like if you have the mass power of the rocket, what happens? You can't go to space, right? Overcome the attraction to gravity. Oh, do you know Friday we don't have class?
oh yeah, they were talking about it.
Do you like no class?